Okay. Again, if you want a context for these things, you can find it under this course review. There's a list of the statements that I'm addressing. If you're in the course, it's under the 1905-02 document, and you'll know what I mean. Okay, so long division. We want to illustrate long division. I'm going to illustrate the simplest case where we're dividing by a linear function. Okay, and we don't have any missing terms here. I've got one that's kind of redundant. I didn't mean to put a square on that one, okay? So we have this division, so we can do it. Let's put a number in front of x to the fourth here. Let's just make it 2x to the fourth, okay? Now, what we want is a quotient up here. We want the quotient multiplied by the divisor to match up to the dividend, okay? And those terms, maybe they're getting a little antiquated since we no longer really do much with long division. But anyhow, so we're going to put a 2x cubed here and explain a little bit about why that works, but you just get the process. Okay, 2x cubed times x gives us 2x to the fourth. So if our quotient has a 2x cubed, then when it's multiplied by x minus 3, we are going to get 2x to the fourth. Now, 2x cubed times negative 3 is negative 6x cubed. And I'm not sure I want that to happen, so I'm going to change this coefficient to negative 7. Okay? That'd be a little confusion if these matched up. And I don't want to bother explaining it. You can read it, you can practice it. Okay, now, so I've got 2x to the fourth from this. So if I subtract 2x to the fourth from 2x to the fourth, this tells me what more I need, which is nothing on the x to the fourth. Now, I have to subtract the negative 6x from the negative 7, which means I have to add 6x to negative 7, and I'm going to then still need a negative x cubed. Okay? So I just think of subtracting whatever I've got here from this. Subtracting negative 6 of something is the same as adding 6 of that something. And if I add 6x cubed to negative 7x cubed, I get negative x cubed. I'm going to see in a minute how that works out. So x goes into what I still need, which is the negative x cubed, negative x squared times. So I get negative x cubed when I multiply this, and then I get plus 3x squared. Okay, I'll put a line there, we'll see why. Okay, so now we can see where we are, because if I multiply 2x cubed by x minus 3, I'm going to get a negative 6x cubed. If I multiply negative x squared by x, I'm going to get another negative x cubed. And that'll add with a negative 6x cubed to give me the negative 7x cubed that I wanted here. So I can see that the negative 7x cubed is taken care of by this negative 6x cubed that I get multiplying 2x cubed here. And this negative x cubed I get when multiplying this. Now if all you want to do is focus on the process, okay, but some people like to understand the process. Okay, so now what do I have? I've got all my x to the fourth and all my x cubes taken care of just by having these two terms. I don't need any more, and that's probably a good thing because I'm not going to get any more. Okay, so now I've got a 3x squared, because if I multiply the negative x squared by negative 3, I do have 3x squared just from this much of my quotient, but I need 5x squared, right? So I'm going to need what? I'm going to need a couple more x squareds. Well, in doing the process here, in imitation of what nobody remembers about doing in long division, I bring the 5x squared down here, and then I subtract this from this, leaving me 2x squared. Okay? Then I divide the x into the 2x squared to see what I have to have here to get the 2x squared that I still need. Now that I've got the 3x squared from here. Okay, so x goes into 2x squared, 2x times. 2x times x minus 3 gives me 2x squared minus 6x. Okay? Now again, I can see that the 5x squared I need here came from here when I multiplied the x squared by this, and from here when I multiplied the 2x by this. Okay? Now, I need negative 3x, I've got negative 6x. That tells me that I'm going to need a plus 3x to add to the negative 6x, so I just end up with negative 3x. But the formal process, okay, bring down the negative 3x, subtract the negative 6x from the negative 3x, and we get 3x plus 5. Okay? And now again, I can see that from the 2x here, I'm getting a negative 3x. And if I where am I? I didn't do it yet. No, I haven't. I don't need to have done it. Okay. From the 2x here, I get a negative 6x. And then it leaves me a 3x that I still have to get. So when I divide x minus 3 into this, I get a plus 3. When I multiply that out, I get my 3x minus 9. Okay? So now I've got the negative 3x, and down here I've got a negative 6x and a 3x that add up to a negative 3, that add up to a negative 3x, which is what I needed. So it's all there. Okay? Now I subtract this and I get 14, because negative 9 subtracted from 5 gives me 14. So my remainder is 14. And I could write remainder 14 here, but instead I'm going to write plus 14 over x minus 3, because if I multiply 14 over x minus 3 by x minus 3, I get the 14 that I need to go with this negative 9 that I got from here to add up to this. Okay? Now the process, just the algorithm, I divide my highest power term here into the highest power term I've got left, and I write down what I get. So I multiply that by this, these match up. So when I subtract this from this, I get 0, and then I've got to remember to subtract this from this. Okay, which means I add the negative of this. Okay? And then I just do that at every step. So I multiply the negative x squared by x minus 3, I get negative x squared, negative x cubed plus 3x squared. I've got a 5x squared here, so I just bring that down for reasons that I just explained, but I just say bring it down. Subtract this from this, I get this. Divide the x into the 2x squared, I get 2x, multiply it, and keep doing that. And that's the algorithm. Again, talked about the reasons behind the algorithm, but that's the algorithm. Okay. And that's long enough, so I'll stop there and then we'll go on to the next one.